Hey, Amalia. Morning. Do you hear me okay?
I can hear you. Okay, yes.
All right, perfect. Okay, let me go ahead and screen ready.
I think Ramya said she will lead the discussion today, right?
Sure.
The fourth one? Or are we still on the third one?
We're on the fourth one, but
Morning,
I
everyone.
think we talked about notes as well as maybe an exercise. So we'll just wait till the others are here though. Hey, Ramya.
Hi, good morning.
Morning. So there's talk of you leading the new?
Yeah, I read yesterday and took some, have my text. So as and when you go through the pages, I'll highlight the important points. I read
Okay.
probably like 15 pages. Hopefully that's enough for today.
Yeah. Okay. Do you want to, you want me to have the screen up or do you want to have control and share your screen?
I don't have a Kindle notebook, so yeah, you can have the screen up. That would be great.
Okay. All right. Why don't we start then?
Sure.
7:34. The others will come soon, I'm sure.
Yeah. So this chapter is basically about two things. One is encoding and another is evolution. Evolution means when you want to change your software, what changes? Your application code can change and your data model can change. So if the data model changes, application code does not change, how do you deal with that? Or your code changes and the application, and there are two concepts like forward compatibility and backward compatibility. That is what they talk about evolution in this chapter. Encoding specifically deals with when you are writing your applications or when you are writing your program, when you're writing any logic in programming language, we use data structures like maybe hash maps or lists, anything to deal with the data manipulation at our programming end. However, when you want to transmit this stuff over the network, or if you want to save to a file, they get converted to a sequence of bytes. So changing things from programming mode of operation into a bytes, which can either be transmitted or stored, is called encoding. Encoding is also called as serialization or marshalling. So things to highlight in these two pages are what is evolvability, making change easy. Then they talk about schema migrations for both the schema-less model and that content. Then coming to the next page, they talk about when the software is evolving, how do we update it or anything. With the server-side applications, we always have option of when to do. We can update the server software for a few nodes, then roll it out gradually to all the other nodes. For the client-side application, like when an Apple sends update for an app or something, it's up to the user to install it and we don't have any control. So those two are the key points in this page. Then the next key point in this page is forward and backward compatibility for evaluation. Backward compatibility means newer code can read data that was written by older code. That means your data model has evolved, but you want and your newer code has to be backward compatible. Let's say a column is removed and or a column has been something added. We'll talk in detail about this backward and forward compatibility. Basically, every time when they talk about compatibility, they talk about a 2x2 matrix, new code, old code, new data model and old data model, and how these 4 columns in this 2x2 matrix behave. That is precisely compatibility. I can make a notes for this with the 2x2 matrix, the columns being old code, new code, and the rows being old data model and the new data model, and mark exactly what is forward compatibility and what is backward compatibility. They also say it is easier to, in most software applications, we are taking care to meet backward compatibility because we know what was the old code and we know what was the old data model, and we can take precautions to when we evolve the software or the data model to be backward compatible. Forward compatibility is harder to meet. The last part of the chapter, and the next they jump into data formats.
So before we go there, right? So one point I wanted to add is, so they say we don't have control over client code changes, right? In our organization, we have some workaround for that. So we kind of selectively enable or disable a feature. So upgrade is pushed up. I mean, we don't have control over when the client users will update the client, but we do have control over whether we want to enable a feature or not. By having a flag, a Boolean kind of a thing that we return as a REST API response, and depending upon that flag, we either enable or it's kind of a rollout technique that we use for client side changes.
But even that flag, user has to install that software to get this.
Yeah. So the client has to get the upgraded client code, but when we can control when to enable a feature and when, if something is wrong, like we can roll it back, we still have some control over it.
Makes sense. Great.
On the other thing that I wanted to say was, so the forward compatible, the 2x2 matrix that you were saying, Ramya, is it there in this book or like is it?
No, that is just my way of understanding how data model and code, if they evolve, forward compatibility. Old code will work with old data model, new code will work with new data model, and the other 2 entries in the 2x2 matrix correspond to backward compatibility and forward compatibility. For me, drawing this matrix helped me to understand things better because they use this forward backward compatibility throughout in this chapter.
Makes sense. Yeah. This is
so the confusing part is you would think that the schema change and the code change will go together, right? Like when you update the schema, you have to update the application code to handle it. So is it possible that you change the data model and not change the code? That's
what happens in forward compatibility. Older code can read data that was written by a newer code. So you have, let's say, a client's application or server-side application, right? Some of them are running in old data model, some of them are running in new data model because they have staged it and whatever, right? But there can be cross reads happening. A new code can write something into a database which has an additional column or remove a column, right? And then your old code should still work with this change in the data model.
Right. Yeah. So that's easily achieved with schemaless because the database does not freak out when it sees a new column, even if the database supports inherently adding a newer column. So as long as your older code is written in such a way that it can handle null pointers and stuff like that, you're good.
Yeah, partly yes. I also think if your application code, so when they say schemaless, right? Who is dealing with the schema here? Currently, the application is dealing with the schema, right? Instead of the database. So they push the problem to the application layer. It depends on, as you said, the code. If it is not well written, then we will even break there.
Yeah.
So next section, they briefly talk about several formats for encoding data. As I said, encoding is a process of like if you have some data structures in memory, now you wanted to transmit this data over the network or save it to the file. So how do you change from in-memory data structure to a format of sequence of bytes that can be transferred over the network? We have textual formats like JSON, XML, and we also have binary formats like protocol buffers, Thrift and Avro. Protocol buffers is from Google, Thrift is from Facebook, I believe. Then the last part of the chapter deals with how do we use these protocols in order to do a client-server communication, either using a REST or using a gRPC. Yeah, so the highlighted point here, serialization is the key. The next few pages deal with serialization. It is also called as marshalling, parsing, and everything. They also say this serialization should not be confused with the database serialization, where when you have multiple processes or multiple transactions happening, there is a concept called serialization of transactions for the database too. That helps with the asset property of the database, right? It helps with like when multiple processes are accessing the database, the requests are sent to the database such that there is, at the database end, it looks like only one process is writing the content serially.
Okay, yeah.
So then they talk about, so if you wanted to just send the data over the network, a lot of languages like convert these in-memory databases into a sequence of byte. A lot of languages have their own way of doing it. I know Python has pickle, Java has something else equivalent of that. So why don't we use this, right? The main disadvantage with this, if you wanted to have a cross-language compatibility, my client side is Python, but my server side is Java. Typically in machine learning, that's the case. I cannot use either Python pickle or any of the language supported encoding formats, because the other language, which is dealing with the data, cannot decode it and make sense of this. So that's the main reason we needed to have some framework which is cross-platform or cross-language. The next they talk about is, if you want to encode something, I'll talk from a Python perspective, right? There is a library called pickle or a DIL, which we can use for encoding. And how encoding works is, let's say you are defining a class and the class uses some external dependency. When you encode, you need to that external dependency should be compatible with the library which you use for encoding. Some libraries don't support, there are things of what each library can support for encoding and what they cannot support. That's what they talk about. In order to restore the data to the same object types, the second bullet point, decoding process needs to be able to instantiate arbitrary classes. And it can cause some security threats because your application code, if it can decode arbitrary classes, external dependencies, that could be, it can be detrimental to your application. The third, problem they talk about here is versioning. Let's say your encoding used some version of your external dependency, but the decoding doesn't know. Here, dependency you can think of in Java as a jar file, right? When you have external dependencies, how do you specify? It's a jar file, right? Or your Maven or Gradle scripts, right? For if your main application has dependencies or main Java code has dependencies. That is versioning.
But why are we talking about dependencies though?
When you serialize your data and the data is produced by some class or something, you need to also understand, you need to serialize the object. The object can belong to a class, right?
Mm-hmm.
If you are serializing the object, you should know how the class was, you have to serialize the entire class.
Yeah, but what is class, right? It's just it's basically the state of the variables in that class. That's all you are encoding. Why do we have to do the dependency?
Your client. So whoever is preparing the data can have one version of the class, and whoever is decoding the data can have another version of the class.
Sure. Yeah. So whoever reads that and has to build an object out of it, they have to have
same version of class. But we don't have control over that with our external dependencies. External dependencies, if we don't specifically, I don't know how you share things between client and server in Java. In Python, at least we have a version number for dependencies actually pinned down. I'm using this library with this version
But
number.
that's, yeah. So that is, I think there are two concepts that we are confusing. So yeah, like if you want, if you install a library, right? Like if you have a dependency and you install that in your in whatever that Gradle or whatever those dependency management frameworks, you give the version number, but that is not nothing to do with serialization there. Like you are dependent on a library and you know that your code builds with a certain version of the dependency. That's why you kind of take that as a dependency, like that version as a dependency. But for serialization, when you serialize an object, what you're serializing is essentially the contents, the state of the class. Not, I mean, if you happen to read it again, you just construct the bare bones class. What I mean, whether the class depends on dependencies, I mean, for you to actually use it, then it needs a dependency is what you're saying. I think that is not the job of serialization to capture, right?
It's not the job of serialization. That's what they're telling it. It's a user problem, and if you're not careful enough, this will cause problems if you blindly, because this serialization doesn't capture all these contents.
Okay. Yeah, but like JSON and XML also, you cannot, it's not a fair comparison to compare with JSON and XML also, right? Like they also
they are schemaless. Yeah, they are also very free flowing and they are schemaless. And the last problem they talk about here is time taken to serialize and deserialize. It has to be efficient both memory-wise and time-wise, and they say Java serialization has problems. I've not used Java serialization, built-in serialization to comment on this. Has anyone else used Java's inbuilt serialization?
I think the whole idea of serialization is to basically, we serialize it if you want to send some response to the client, right? Why would you do it in Java? Like HTTP is like, we just give it
much
over.
better. Exactly.
If you want to write out something to the file system, forget about the client server, right? In that case, do you use Java's inbuilt serialization?
I've not used. I've not used the native serialization library. I have used the typical JSON, Jackson, which kind of serialized to JSON.
Yeah, this is like probably kind of a little bit old as a data point, but maybe because we're all used to like newer things like JSON. So I kind of feel like maybe this point here is just illustrating a pain point for people in the past.
Yeah. I think when you actually use the inbuilt serialization, it probably captures a lot of the Java language specific metadata, right? Like what kind of class it is, to be able to build the exact class definition out of it. First define the class and then create an object out of it, right? So I think it needs to capture all that metadata in it. That's why it's kind of bloated. That's why they say it's bloated.
Okay, that's a great point. Okay.
Yeah.
So the next section talks about various cross-program language like encoding and decoding formats, right? There are two variants. One is textual. JSON, XML are all text-based, and binary variants like protocol buffers and Avro and Drift. They talk about what are the disadvantages of these textual formats. One of the main disadvantages of these textual formats is in XML and CSV, you cannot distinguish between a number and a string, which consists of digits. And JSON doesn't have a method to specify it cannot specify the precision of a floating point number. Then they also talk
with XML, you can have this XSLT, right? In my first job, I had to deal with something called XSLT. So what that is basically you define your XML schema, and then you give the data types there.
Okay.
So there it enforces. You can say whether we want it to be like floating, integer, and all. But that is a very rigid, a way of enforcing the schema. Like you can use XML without XSLT. Like in the regular XML build.xml, all these configuration and XML based configurations, right? I think they enforce XSLT there because you want the people to follow certain format, so it remains consistent across. You basically you create a version out of XSLTs. So basically that does the validation for you. It won't let you enter any random. It basically fails as a compilation error.
Yeah, they say it as a fourth or third bullet point. There is optional schema support for XML, and it is fairly widespread, but it is up to the user to define that schema and make your application work along with that schema. Yeah, that's optional. Yeah. And the next thing they talk about with these textual formats is they support only human readable text like Unicode characters. And sometimes you wanted to send data apart from human readable text. So what do? They encode it in a base 64 format and send the data in XML. But this increases the size by a few percentage.
I think the action item here is why 33%.
Why 33%? I don't know.
Action item. Yeah, I also was wondering why 33%. I will
Good
get
job.
that. Yes.
Yeah, maybe it's a range. Maybe it's not exactly 33%.
Sometimes when people give these precise numbers, I wanted to give them an explanation or reference at least there where they pick this number.
No, I think it is a precise number because the base 64 is basically the character set is 64 bits, like how many? I always
2 power 60.
2 power, yeah.
2 to the 64.
And
Yeah,
your
so
Unicode
it's
is, and your Unicode characters are much limited, right? So you're basically using 64 bits to represent a smaller character set. So I think that's why it gets bloated.
Yeah.
But they go and use base 64 for non-Unicode C, right? Not necessarily for Unicode. They get around the limitation of Unicode by using base 64. So they can represent more than the Unicode or more than the human readable text.
Right, yeah.
Okay.
Yeah, and this is like for doing images. I've seen base 64 for a lot of that, or big JSON payloads, where you're translating the entire JSON payload into base 64 instead. So I've definitely seen this on the web.
I see. Okay. Yeah, the next bullet point talks about schema, and for XML and JSON, there is an optional schema and how the users or the administrators can enforce it and everything. However, CSV does not have any schema. They can have a column format or a column, and it's up to the user even how to decode a CSV. It can be a comma separated, or it can be a tab separated or a space separated. So CSV, it's really free flowing, and not all parsers implement all types of parsing related to CSV. If there is a custom separator, probably user has to write their own way of reading the CSV. They also said, despite these various flaws, these JSON, XML, and CSV are good for many purposes, for data interchange formats, and as long as people or applications agree upon a common format, these are very widespread. They have widespread use. The next section briefly talks about binary encoding, right? In binary encoding, typically you compress, you express the data, you encode it to a sequence of ones and zeros, and it's typically not human readable. And why it is used? It may be faster to communicate, and it may take less IO bandwidth to communicate using binary encoding. So those two are the main use cases for binary encoding. Do you know why it is specific only to internal to your organization? Because there is a first bullet point which says, for data that is used only internal within your organization, there is less pressure to use a lowest common denominator encoding format. Maybe that's true. When you are dealing with external systems, you need to know what external system can accept, but internal systems, you have full flexibility to choose what you want for all the internal applications.
No, I think binary encoding, right? Like, for example, if you're using the JWTs, right? Like the tokens.
Yeah.
So there is a limited, that is the most efficient way of storing. Basically, you are, let's say you want to encode the permissions when you give out a cookie, right, to the user. You want to say what he can do and what he cannot do in the client. Then there are there could be many features that your client can do, but you want to enable and disable selectively based upon the token contents. So what we do is, so we kind of encode this in binary format, and the clients kind of look for those bits to be set to enable or disable some feature for the client depending upon his license or whatever. Basically the token is encoded with like each bit in that token represents a feature kind of class. So it's a contract between the client and the server, like how to. So it's internal to us. Like it doesn't make any sense for anybody else.
I see. Okay, makes sense. They also say here brief JSON and extensions. Some of the extensions of JSON support or binary, even extensions of XML. Have any of you used a binary version of XML or JSON?
I've seen Json a lot, but I haven't used any of these other ones here. And XML seems to be kind of like going away, in my opinion.
I see.
As far as like internal formats, I was thinking, actually, it's kind of funny. A lot of people, like, even though we have so much technology now, still like use CSV or Excel and just pass that around. A lot of people internally get confused about, I mean, like, I'm not talking about the programmers, but I'm talking about like the people who use the software. So, yeah, to them it doesn't matter.
Yeah. In machine learning and the data engineering world, we use a lot of Parquet and Arrow also. They are the binary formats we use for writing out to a file or sending some data to a server for probably inference or something. We try to do a Parquet format or an Arrow format. They are cross-language. Apache open source binary encoding format. They're also columnar storage, but they have this encoding when they store into columnar.
So lot here. So what do we mean by binary encodings for JSON? Like, are you saying that you use it in data analysis? This binary encoding of JSON?
No. I was talking about a different thing. Here, they say there are various extensions of JSON which are binary. So yeah, Vijay had worked with BSON, which is one of the binary extensions of JSON. So I was asking if anyone worked on that. Yeah.
No. So why would you want to do that? Is that going to be more memory efficient?
Yeah. So basically, it's more lightweight. It allows for lots of huge data to be saved. Again, think images. Think like if you're saving big amounts of data to a database like MongoDB, then Bson is a little bit better. It's easily stored and it's great for sending data. It's efficient, handles additional data types, kind of like outside the realm of JSON, right? Like that's what they were saying earlier in the beginning of the chapter, is that JSON is good for a few types, but then like JavaScript is not very good as a language in general at handling types. So it can mess up things like floats. And you don't really get like a lot of great data structures in JSON. It's just
I thought for like, are you saying for media, like if I thought JSON is very text based, it's a based representation. Like we are not talking about media when we are talking JSON based encodings, right? The media is a different problem. Like pictures, images, and videos, they are not. They can't be represented in JSON, and we're not talking about that here yet. I guess. This is mainly saying if you have a huge JSON file, instead of kind of transmitting it over as text, you convert that as binary to make it kind of compress.
Yeah, I mean, yeah, you're right. Right. I've seen. So when I think of media, Bson, I think sometimes of media, but I think, yeah, there are other things like we can, it says right here, like, you know, let's see here. Here's like a little graph or a matrix, I guess, table. It just kind of tells you that it's better at these kind of things: speed, space, encoding, decoding, parsing, data types. And I guess like that's the main thing, right? Bson offers more data types. And so this is why you would probably go the route of Bson.
Oh, so okay, so it does say that you can transfer binary data if you have like other.
And usually like media is like sent as blobs by binary long object. I think that's what it's called. Yeah, right here, binary data, typically images, audio, media. But again, like, I don't know if people like largely, I have to go into a use case, but like, I don't know like how much is sent through JSON and Bson. There are different strategies for approaching this.
Cool. So they have an example of a binary format for a record, and I think that will give us a fair overview of how JSON binary formats, how a JSON is converted to a binary format. The next page. Is there a way we can place this page and the next page side by side? So here we have a schema or a record which has username Martin, favorite number, something, and interests.
Yeah, so here, let me just, I've changed the column size again.
Yeah, or we can just remember this and we can go to the next page. So it has.
The only reason, yeah, like the only reason I started making it single page is because like when I highlighted it was highlighting both pages. So
Okay.
yeah.
So this is a record, and we have 3 objects in this record: username, favorite number, and interest. Username is and the keys are all strings. Value Martin is a string. Favorite number is a integer, and interest is a list of strings. Right?
You know what this means, right? 1337.
No, I don't know what it is.
It's LEET, like leet code.
Oh, okay.
Yeah.
Okay.
Like there's a way that I remember this from back in the day when I was like 12 or something, or 13. People used to write like this with numbers. If you use your calculator, you can write hello with 43110.
Mm-hmm.
You know, and like there's a whole like kind of, they call it leet speak, I guess, if you were to look it up. Find like all of these like different, like, yeah, sometimes you'll see it all over the web. So elite speak. Anyway, it's funny to see that he threw that in probably on purpose to like indicate to others, hey, I'm a lead coder, or I know this stuff.
Teenage kids to communicate in an encoded format without the parents or teachers knowing.
Exactly. Yeah, we used to do this like back in the day. I still think like some people do this, like you know, like it says here, elite hacker, right? Like as a laptop sticker. So okay. If you know, you know. If you don't know, then like right here, this is ass for shit. But your teacher probably wouldn't know unless they were savvy. They're talking about the 90s though, and the double O's. Like this was back then, like, yeah, people didn't know, like, what is this? Like nonsense, but people who are in the new. So he's signaling.
Yeah, interesting. I didn't know that either. Yeah.
I'm pretty sure you guys are familiar with this one, noob. That means like a newbie, like somebody who's just learning it. So like if we were to, you know, if I were to go and apply for a job, you know, at Facebook or Amazon or something, they'd probably say, what a noob, you know, because like my skills are on system design, data structures need to like improve, right? So I'm a noob at that point. Okay. Oh, this is one more, owned and pawned. So usually like if you're like, if an interview is really hard for you, you can say you got owned or you got pawned, right? Like that means like you lost the game or something like that. So just food for thought, or just fun tidbits, trivia here.
Wow, nice. Yeah, I didn't know all about it. I'm curious. I'm going to read that wiki after the session.
Sure.
Yeah, so we have this record and we have an example of message pack encoding in the next page. So if you can go to the next page. So just remember this one, like it has 3 records and one is a string, one is a number, and one is a list, right? We'll skip this and go to the next diagram or a figure. I can explain it with that, right? So all that content in a record, it is packed into a byte sequence. They say it is a 66 bytes. And they have these vertical markers in the byte sequence to break it down into different elements, right? In this, one thing to key about this message pack is they store both the, I kind of see they transmit the schema also along, because they have username followed by the content for the username. And they have encoding for favorite number followed by the favorite number itself. So all this username, favorite number, and daydream, interest are kind of a schema for this record, right? So this encoding encodes both the schema and the actual instance or the value for that element. So here they say 83 means it is a 3-element record. Next, they say A8. A is nothing but probably it indicates a string, and 8 indicates it's next whatever is following is an 8-byte string. And then next they have a Unicode representation. I think it's UTF-8 for each of these characters, USERNAME. Next, they say it is a string, but it's a string of byte 6 length, or byte length is 6, and they have marked in there. Next, they say it's a string of length 14 and favorite number, again a UTF-8 encoding. Next, they say they have an integer uint 16 and 1337 is represented in a 16 bytes. So 05 is the upper 8 bytes and 39 is the lower 8 bytes. Next is the string of length 9 interests. Here, they break it down into furthermore. After interest, what they say is you have an array entry. So 9 represents array entry, then 9, 2. And the 2 represents you have 2 elements in the array. If you have number of elements more than 9, right, obviously you can have 10 elements in the array. In that case, what they do is they have an encoding format which says, my length is now specified in future bytes. And they say how many bytes after 9. Let's say your length is like 56, right? You cannot put 56 after 9. So they simply say 9 and next element is probably 2 or some encoding there which says read the length from the next field, and the next field will say how many bytes represent the length of the array. Here, since it is true, they simply say 2 immediately after 9, and each is a string. They again have a string AB and A7. A represents string, B represents the length, and 7 represents the length. And they have the UTF-8 encoding. So after all this work, they say if you count the number of bytes, it's 66 bytes long, which is a little less than 81 bytes taken by the actual textual JSON. So even though we did all this encoding and decoding with these formats, it's not giving us a lot of space efficiency. From 81 bytes in the original data, now we went to 66 bytes.
I see. So to recap your point here, the 2 is for 2 entries. Is that what you're saying?
Yeah, 2 is for 2 entries. If you have more than 16 entries, right, you cannot represent that because it represents after F, right, or more than 15 entries. So what typically happens is after 9, there will be some setting, or maybe F is reserved for saying, okay, when you have an F, read the length from the next byte. And the next byte or a sequence of bytes represents the length of the array.
Okay.
So I think the real question is, how are you doing this demarcation, right? Like, let's say I had 12 array elements. Would I say 9, 1, 2?
No, 12 means you can still represent, right? Because each 0 to F, right? So 9 you can still.
Hexadecimal.
Is this hex? Oh, it's a hexadecimal. Okay, so what happens if it is more than?
More than so let's say 20, right? You have 20 elements. Then what the number follows 9 is they will reserve some character from 0 to F to say, this does not represent the length. This represents a special format where you have to read the length of the array from my next byte. So let's say they have 9F and F represents read the length from the next byte. And in the next byte, they will have a first field saying 2. The 2 means my next 2 bytes represent the length. So it will be 9F2 followed by the number of bytes representing the length of the array.
9F. So F meaning
Special content saying F is not a length. Now my length is specified in the next byte.
right.
And next byte, the first thing has to be how many bytes are there in the
in the length representation.
Length representation.
Okay.
I
That's
see.
so it's almost like a compiled language, right?
Yeah. I don't know if you're familiar with variable length integer encoding. Even numbers, like instead of we specifically saying uint8 or uint16, we always allocate 8 bits or 16 bits, right? You can have a variable length based on encoding, and that is one of the,
Oh, I didn't know.
Yeah.
So this is all is this that variable length encoding is in the context of the serialization?
Yeah, here when they say that anywhere they wanted to specify the lengths or object lengths or numbers, right, you have to have a variable length encoding. If you have a fixed format, right, you have to always allocate something, and you are very restricted. You cannot transmit something which is more than maybe let's say making up a string, right? You cannot transmit a string which is more than say 20 characters. In order to have a free-flowing format, you can transmit strings of any number of characters. You definitely need to have a variable length encoding here. Even arrays of any number of elements.
Got it. That is really good reading and explanation, Ramya. Makes it much more approachable now. I'll go back and read this and
So for all these encoding formats, the key is some variable length encoding, and how do you represent that variable length in this encoding format. So they always reserve some special character saying, okay, read it from the next block.
Right.
So this is the message pack. And for the same record, now they compare drift and protocol buffers, right? Drift and protocol buffers are again encoding formats, binary encoding formats. One from, drift is from Facebook. Protocol buffers is from Google. I highly recommend the gRPC paper. If you have not read, I liked it a lot when I read it long ago. After reading this section, I wanted to go back and read gRPC again from Google. Here, in both these protocols, right, the difference is they are constructing a schema and they are storing the schema also in, this is a great link. Yeah, we can go to that link and or use it. We can.
So do you want me to stay on this page? Or
it's up to you, whether we wanted to discuss gRPC now or gRPC comes later in the chapter, we can discuss then also.
Either way.
We should read, all of us, we should like maybe next class come read that link.
Yeah.
Then it makes more sense if we have read it upfront.
Yeah,
that's fine.
Yeah. So here, drift and protocol, you need not know about gRPC and all. It's just it's another encoding format. The difference between message pack and this encoding format is here they define the schema in a schema interface definition language or in some language format, right? And they can version the schema. Schema is also stored somewhere in the database. So you know how the schema evolved. In the message pack encoding, we indirectly transmitted the schema also. Like I said, we transmit username, favorite number, and daydreaming, right? That occupies space actually, correct? And every record, we always send this username and interest and favorite number. So it's kind of not actually required to send the schema along. Yes, the application need not have access to the schema, but you're wasting a lot of space by encoding the schema in the record instance of a record. Here they avoid that in these two protocols by saying we are not going to transmit username, favorite name, and interests field names, but we are just going to transmit the values for these fields. In order to do that, they should both the sender and the receiver, right, or the encoder and decoder need to have access for this schema. That's why they define the schema and persist it somewhere or save it in a common database. Another point here is, since the schema is fixed, right, like the previous page, they had a schema, and this is a schema for Google Protocol Buffers. The first one is for Thrift, and the second one is same thing. They say which is optional and which is required field, and the same content, which is a string, integer 64, or a list. Here, if you see, there is a list of string in Thrift interface, but in protocol buffer interface, there is no list. So they simply say it is a repeated. Repeated means it can be a string which is repeated there are three elements in the string. Because the schema is fixed, they say when you have your in-memory database and you want to convert it to this format for transmission, there can be an automatic code. You can have a code which can be generated by CodeGen, and you can encode using that automatic code. Users need not worry about correct encoding and decoding. All this will happen using your application code can use a generated code from this, which exactly transmits data, figures out how to represent your in-memory data in this format. So those are the basic things about Thrift and protocol buffer. Here, as you can see in the Thrift, you have some tags 1, 2, and 3, which represents the field. They are like a shortcut representation of the field. Instead of transmitting username, favorite, number, interest, now you'll just transmit 1, 2, and 3. So I would say this is not completely schemaless. It has some reference to the schema. This is an example record from a binary Thrift protocol. It says, yeah, as you can see, field tags are transmitted 01, 02, and 03, and each field has a length. Like Martin has a length 6, and they transmit the length. Similarly, integer is transmitted. So field tag, field type, and field length, followed by the actual instance of the record.
So it's a little bit more optimized, right? Like that's kind of like the idea, is that you don't have to send a huge payload with the entire shape of the object. You can kind of get away by saying, okay, we're going to predefine what this should look like.
Yes.
And then it's almost like, I think I've seen this in GraphQL, right? Like I was bringing this up the other day, like GraphQL is like based on this gRPC model. And then you have to create stuff like types in GraphQL and resolvers, and then they map over to like a database, I guess. I was going through this, you know, as a tutorial here. So here's your type, you predefine it, right? And then the resolver converts that type up here into a return value. And then you basically can return data. Your data can be like a separate database from, you know, from like MongoDB or like PostgreSQL, but you bring that into context, and then that's what gets resolved. So see, like await the client connect, and then return back the query from the table, and that gets resolved back. You know, so I think this is a pretty good example of what this chapter is talking about here.
That would be great. Yeah, we should add that link also. I can go and read it up after the session. Yeah.
GraphQL, yeah, I highly recommend it.
Sure. Yeah. Yeah, they say in Thrift there is a binary protocol and a compact protocol. Compact is a little more better protocol. There are 2 versions of the protocol, and compact is more compact than the initial version of Thrift's binary protocol. Because in binary protocol, they have, for an integer, they always use fixed number of bytes, right? Like uint 16, 1337 is a uint integer 64, so they have 8 bytes to represent the number. even if the number occupies only the lowest 2 bytes, all are zeros, we still waste a lot of space there. So one improvement they made is they represent this number in a variable length encoding format. So far, we have seen variable length encoding only for lengths or length of the strings or length of the field. Now they are applying that variable length encoding even for number representation, like integers or everything. So if you turn to the next page, you will see the number 1337. Now it is F2 and 14 instead of, and it occupies only 2 bytes instead of the usual 8 bytes. So this is a small improvement they did in order to make it even smaller and compact their binary protocol. Yeah. Next is protocol buffers. Here again, they say how they encoded. The key again here is variable length encoding. They have a field tags again, followed by type of the tags, whether it is a string or a variable length, or if it is a integer. And then they have the length of, every string will have a length field and every integer will have some length field followed by the integer number itself. After all this is like 33 bytes. They also say that they mark some field as required or optional, but it makes no difference on how the field is encoded or decoded. This is only for your application code to enable a runtime check if that field is not set. That's about it. I also read about field tag schema evolution and everything, but I wanted to make a 2x2 matrix to go over that. I'll make it offline in the notes, and that will be easier for discussion rather than me talking through this. If we have the 2x2 matrix, and we can just go through these next few pages within 5 minutes, but I didn't have time to prepare for that 2x2 in an online format.
Yeah, take your time. I think you're doing a great job reading this chapter, honestly. So
yeah, I think
we
it's
can
very
come back.
dense. I think, yeah. I honestly didn't completely grasp what was spoken today. So I think, yeah, we should pause here, go back, read,
Yeah,
come back, and then discuss. Yeah.
Yeah, it's a pretty long chapter here, kind of just going through and seeing how far it goes.
The next section talks about forward and backward compatibility, and then they come to like how data flows through databases, either gRPCs or REST API or services like that. So there are only 2 sections after this.
Okay.
Yeah, so let's continue this discussion about the protocol buffers and gRPC next session, right? I think the action item for next thing is basically read up about those and kind of form a framework as to when is like current pros and cons of each, and where is it more appropriate to use kind of understanding before we move to the next section, because just reading up and not kind of putting it in context is helpful, right?
Yeah. For me, the takeaway from this encoding is like, oh, let's see how you transmit a message and how everybody tackled it and who came up with the most smartest way of compressing all the information in lowest number of bytes. So I didn't pay much attention to how people transmit schema, people transmit a smaller version of schema like field tags. Now, in the next page, we will also talk about Agro, where they don't transmit any information about the schema at all. They will simply transmit only Martin, the daydreaming and hacking the values for each record. So that's like trumps all these previous encoding protocol we have looked into so far. So it's one framework is an improvement over the other and how they can represent everything. The key is you can have a schema also in a database, and it can be version, and your code can know which version of the schema it is using. Or with every record, you can store a version number of the schema that it belongs to, which will help in both forward compatibility and backward compatibility, which we can discuss in the next few sessions.
Yeah. So one other thing, right? Like we also should understand where is this applied. right? I can tell from my experience that we use this encoding in encoding our cookies. So cookie have 4K limit, right? I think it's 2K, not 4K, 2K limit. So your cookies, so as your application keeps growing, as you keep adding features, right, your cookie size grows because you need to encode all that information that you need to convey to the client in that cookie. So it is a limited string, and you are supposed to densely pack all that information in that. So that is where that is my experience, where we had to use binary because like there is no other option. Like we basically are looking at bits and kind of inferring. So yeah, I mean, that's why I appreciate this topic, because we always run into this issue as to, okay, like we have an alarm system where the cookie size grows and then it's a step 2 for us. Yeah. But yeah, I would be interested in like knowing people's experiences as to where they have, why were they were pushed to.
I have to run to the work. Like I have a meeting at 9, so I have to start driving. I'll quickly
No
just
worries.
and drop off. So
Okay.
we are RPC based client server. We are a platform company. So we are and our platforms, all the clients interact with our platform or a software using a RPC system, and we have a custom binary encoding when they want to interact with our software. So yeah, I'll talk about more in the next session. So
Sounds good.
bye. Yeah.
All right. Well, thanks everyone. We'll stop here, and we'll see you next Wednesday.
Yeah, see you next Wednesday. Bye.
All right. Thanks a lot. Bye.